Good morning, everyone. My name is Ray Garrett. I'm the manager for the Utilities Records Integration Department for the University of Michigan. We take care of documenting the utilities on campus, and we get into a lot of GIS, some AutoCADs, a little bit of BIM, but mostly GIS. And we're looking to take and build models to represent our campus in 3D. And our current path of investigation is CityEngine, and I'm going to go over that with you today. So why do we want to do 3D? We want to take and be able to better visualize where our assets are in campus. We want to take and better locate where our underground assets are. We're responsible for building lights, and we have issues for where they're at in the third D on a building. To be able to take and give that information to the people going out and doing the PMs or the repairs on them. And on our campus base map, it doesn't show up very well. They don't know what the equipment to take out with them. And also visualization of outdoor lighting, so that we're going to take and add lights, and we can take and put in an intensity for the bulb. How much coverage do we have for our street lights on campus? Planning and 3D routing. So when we first started out on this, the question is, what product should I use if I'm going to build a 3D campus? We took a look at a number of different products, and this is by no means an exhaustive list. It's just the short list that we took a look at. So Rivet has difficulties over large campus areas. We've got 3,300 acres. And when you try to take and put all the Rivet models into something that large, it tends to bog down and bind down. CityGML, there's a number of different viewers out there for CityGML. We didn't want to take and pursue that path. All of our data is currently in Esri, SDE servers, and we've got a good long-standing relationship with Esri, so we decided not to take and switch any of the data over. ArcGIS Pro, you can do a lot of 3D items in ArcGIS Pro. Currently, we had some licensing issues with how to take and get facilities separated from campus. We believe that we have a line on how to correct that, and we're going to pursue that. ArcScene didn't have enough capabilities for us for what we wanted to take and do and display. CityEngine, from all the demos and everything, it looked like it was a pretty good product. It could handle large scale areas. And Urban Circus is another product that was looked at, and actually our AEC group did pursue the Urban Circus path. And the jury's still out on whether we're going to pursue Urban Circus from the AEC side. And there's a lot of other products out there. All right, so what's needed for a CityEngine project or any 3D project? You really need to identify what the objective and the audience is. So the reason that AEC is going with Urban Circus versus something like CityEngine is that they're looking for photorealistic campuses that they can do presentations for donors to bring in large sums for buildings and things, and to present to the regents. Our take is we want to maintain the assets. We don't care what the level of development does not need to be as high for us. And I'll show you some of the differences that we're doing as we go forward. Another thing you need to identify is what the scope and size is. It's very easy in a number of different packages to do 3D on a single building level. But when you start putting 1,100 buildings in there, it makes a big difference. And again, how many square miles or acres are you actually trying to cover? Very important one that we didn't really take a close look at in the beginning, and I'll show you some consequences that we had along the way, is your data 3D ready? There's a lot of things that you can do to take and represent your data on a 2D base map on the web, but when you try to go into that third dimension, you'll most likely find a lot of holes in there if you've been working on a 2 or 2.5D basis in the past. Unless your campus is very flat, you'll need some kind of terrain model to put your campus on. and then what are you going to take and display on that terrain? You're going to use aerials or a base map to be able to show your geographic areas. Then you need your building outlines or floors and what assets you want to take and put in there. And with any new product, you need a lot of time to devote to build your models out. So we started with a DEM with buildings subtracted, and this gives us our base layer to take and put our campus on. So we started with the idea, because when you take a look online and you're looking at the presentations from Esri, you're looking at some pretty good backgrounds for it. So we had Pictometry do a flyover for another project, and we had 3-inch accuracy in the aerial, so we thought we'd just bring those in and lay them on top of the terrain. Well, this is what it looks like in CityEngine from a Diag campus view. Our 3-inch aerials will take and bring in a very nice, tight, crisp view. But then when you bring it into CityEngine, there's a problem where CityEngine takes and it has a size limitation for what aerial you can bring in. So it will take and adjust whatever density you have down to 1024 by 1024. So your resolution is not very high at all, bringing it in. Now at the UC, they said they were working on that, and 2016, they're supposed to take and be addressing part of this issue. And but aerials weren't really a very good option for us for what we were trying to represent. So as I mentioned, the CityEngine automatically changed it to a lower resolution. Another issue is that CityEngine takes and processes all of its graphics, all of its images on the graphics card. So you need a fairly beefy graphics card, and this is true with almost all 3D products, to be able to hold the images in there. When you're going to take and build a campus, you shouldn't take and start with a small test area. You really should start with your largest extent and see how well the package you're looking at handles that largest extent, and then you can work your way down. If you start with a small extent, the package may not be scalable up to full size. So at the UC, we saw a presentation where a person who was taking and driving a 10 over the terrain, and they were taking a base map, and it looked pretty good. And we had a halfway decent base map, so we said we would try that. And so we took our base map, and when you're zooming into the Diag area, and even closer, it comes up extremely sharp for what you're looking at. Now, this is not necessarily what you're going to want to show to the regents, but from a maintenance standpoint, for getting around on campus and showing the assets for facilities maintenance, this is great for us. It gives them sharp clarity for the differences between the grass and the sidewalks and the other assets that are out there. Doesn't have the distortion of the aerial, and we're perfectly happy and fine with this. It takes a bit more work to put a 10 on versus an aerial, but it's well worth it in my opinion. Okay, so when you're building up your buildings, what level of detail should you be using? There's a number of different levels out there, whether you're going 0 to 4 or 1 to 4 or 100 through 500, doesn't matter. For us, from a maintenance standpoint, we're just looking for really block representations. We don't have to have photorealistic of the buildings. We would like to go more than just the extrusion of the footprint of the building. So that's an in-between state. And we would like to see roofs if possible, because we've got roof maintenance that we have to do. So we're somewhere on this scale, shooting somewhere between a high 1 and low 2, depending upon what information we have to put into the model. So should we use textures or procedural rules for building the surfaces? In CityEngine, you can take and create procedural rules to represent all the buildings. It's extremely good for doing a large area that has a lot of repetition or models in it that you can take and put variables into to change them. But it's more difficult if you're doing one-offs, and I'll show you some of that details in a minute. So we tried both. Since we had the pictometry flyover, and we had them in both orthos and obliques, then we could take and send that data out to PLW ModelWorks, and we could take them. We took a 1 kilometer square kilometer section, brought in the facades being derived from the pictometry data by PLW ModelWorks, and we applied them to a number of buildings on campus to see what it looked like. Now this is the same data, and it doesn't show up very well because of the projector. It is much clearer than what is being represented here on the screen. But this is the same data that actually went to the people doing Urban Circus, and that's their basis for the buildings also. So we're using the same basis of information for Urban Circus and for CityEngines. So you've got really three levels. The simplified is just taking the base area of the building and extruding it to the height. Detailed is putting the facades on here or building up models, or you can do something in the middle. And from a facility maintenance standpoint, now you have to understand that we're a utilities department. We don't deal really with doors or windows or other items with respect to the building. We're concerned with the lights, the stuff that's on the ground, the lights attached to the building, and taking and separating the buildings by floor and extruding them by floor, we believe is really good enough for what we're doing. To take and to build a detailed model for each of the buildings is very time consuming to do. And how you would end up doing that is by taking and coding it via CGA, which is computer generated architecture. And it's just a scripting language. It's got most of the standard stuff that a scripting language does, the ability to comment, version numbers, you can do arrays in there, attributes, constants, and then you have rules for how things are behaving. And this is the simplest rule that I've got in the model, and it's for a fire hydrant. And all the assets are brought in, and we take and we assign the rules to the assets, and you can do it on a per asset basis, or you can do it for all the assets that are in there. And this is going out and naming what the rule file is for the object that you've identified, and then what the start rule is. So the start rule here is hydrant. And all we're doing for this start rule is taking and aligning it to the axis. So for hydrants, we're taking and aligning them first to the terrain, and then because the terrain can be on a slope, the hydrant will actually come out perpendicular to whatever the terrain is. So the first thing you have to do is align it to the axis that you want to straighten it up. And didn't realize that at first, and then all of our light poles were crooked and everything and leaning, and scratched our heads for a little bit. And then we're just assigning color. And the thing about color in here, it looks like it's RGB, but it's a 0 to 1 range. So when you're used to working 0 to 255, you've got to convert that all to 0 to 1. It's still red, blue, green, but a 1 is equal to 255 in their, the way that they do it. And then the other items that we do is take and assign, in this case, what is going to represent it. So this is an object file, an OBJ file. It's put in the constants up there to take and tell it what object file to pull out for what you're representing. Because all this is a point on the surface. And then from that point, we're extruding the object based on what the parameters are. Logic in a CGA file, the only thing that they really let you do is a case statement. There's not an if-then-else type of thing or any other kinds of switches or fors, and you really have to take and drive down through the case statement to be able to make things work in the CGA rules. And here we're just taking and assigning a blue color to the U of M hydrants, a yellow color to the ones that are owned by the City of Ann Arbor, and then if we don't have the data filled out, we're assigning it a red color to stand out to us to say we've got a data problem there, to take a look at it. So for CGA, if you're doing one-offs, it ends up taking a lot of time to do. If you're doing a lot of the same thing, it's well worth going into details in the procedural modeling. So for trees, for example, we've got 17,000 trees on campus, and it is well worth taking and building the model for the trees to represent what the trees are. Light poles, we've got 4,500 light poles out there, well worth building the models for the light poles. For the individual buildings, I'll show you in a minute what some of the issues are with that. For buildings, CGA is very good starting with a rectangle, and then you can extrude it, and then you can manipulate the sides and break them down as far as you want. You can have at the end 200 sides on that rectangle by keep drilling down through the case statement, but it'll start with your four sides, your bottom and your top, and then you break that side down and identify which one you want to sub-break, and then keep breaking them down through case statements to get down to the smallest size. Very, very good at doing repetitive tasks. Starting from a multi-side polygon, though, is challenging. So we have floor plans for all of our buildings, or most of our buildings. So what we want to try to do is reuse the data that we have, not reinvent the wheel. So for us to take and use procedural modeling on this floor that's got the light blue highlight around it, just from the sides that I'm looking at, there's over 75 sides on that, on the front part. And if you take a look at the back part, you're going to end up like 140, 150 sides in there. So for me to take and to be able to assign and break this section down into windows and seals and stuff, I've got to identify what face that is out of the 150, and then take and assign the rules to that face. So is it possible? Yes, but it's a lot of work. Because what you'll end up having to do is take and put in a case statement that for this building, for this floor, and then there's 150 sides on here, side number 83, you've got to put the rule in there for how it's going to be broken down, and then break that side down to create the procedural rule. So from existing data, we have very few squares on campus. A lot of the buildings are like this. We find it challenging for us. And to be honest with you, we would probably go with PLW data to take and represent the campus before we tried to take and build procedural rules for our campus buildings, unless it's a brand new one that we're building and we need to show somebody it. You can do interiors through a CGA rule. I can turn off the rest of the floors. Here I've extruded the floor up just 5 feet, and the doors in there. Then we can take and place assets in there if we want. I've only gone up 5 feet for a couple of reasons. One, it's easier to see over the room, but the other real reason is that we don't have good data on what our real door heights are. We've got excellent data on widths, but we don't have heights, heights for it. And we don't have the difference between the drop ceiling and what the true floor ceiling is on our data. So it comes back to the question, is your 2D data really ready for 3D? So in adding assets, a number of different ways to add assets. As I mentioned, brought in an OBJ file for the fire hydrant. Also bringing in OBJ files for the light poles. We've got a lot of light poles on campus that are globe, which makes it very nice and lucky for us. There's a couple of items that you have to take into consideration when you're bringing in OBJ files. When you're taking and putting in a height, because all of our poles have heights to them, so we can be data driven as far as how high it is on the model. Not only are you going to take and change the height, but the OBJ file, when you expand it, is also going to expand the width. So you need to take and for each family of heights that you're going to have, create a different OBJ for that height so that your spans of your arms are in relative size to what you're looking for. So these are typically in the 11-foot range. These can go, they vary, some are 20, some are 30s. We've got some that are in the 40 range, and when we get to field lights, they go up to 60-foot range. And so you've got to take and make different OBJ models for that. Kiosks have, I'm not sure how many campuses have these, but they're just big round concrete structures, and mostly you see the students putting their notices and everything on it. We use them for ventilation for the tunnels is what they're really there for. And then we throw a couple of others out just so that there's balance on campus. But really they're ventilation stacks for the tunnel, and we'll take and we just create a circle object for it instead of a rectangle and extrude it and apply a texture to it. They're pebble stones and apply a pebble stone texture to it, and we're good to go. Trees. Esri's got a good tree model for a starting basis that they put out with their sample data. That's what we started with. One of the things that we had to do and we're continuing to work on is that we have a lot more species of trees than what they have in the model, so you either have to make some substitutions or start working on creating your own models for it. We've got 17,000 trees in the database, and there's a lot of them that we have to end up building if we want photorealistic. And whether you go to a leaf structure, and I'll show you examples of trees here in a couple of minutes, or whether you go with a lollipop type of tree, it's going to depend on what rendering you want. Manholes, we are a utility, so we've got plenty of manholes out there. We're currently working on modeling the sewer and storm, and I'll show you some pictures of that and some do's and don'ts with the manholes. And then tunnels, we're working on those underground also for the assets. And there's other assets that we'll be adding in, but this is what we've got active working on. So this is the same scene as before. We're just flying through with some assets in it. You can see the light poles in there. Tree representations, yellow fire hydrant, Ann Arbor fire hydrant. Just past a blue one. It's one of ours that we own, another one that we own. So it starts looking like a much nicer campus when you start putting the other assets in there. So why are these trees white here? There is a capability of putting a dead tree in there and it looks brown. But the reason the tree is white is the way the CGA is written is if we're missing a parameter and it doesn't fit for the species, it'll leave it white as an identification to take and let us know that we've got an issue there. And there's a lot of data that can be missing, and the tree CGA that Esri put together does a fairly decent job of, if you're missing the data, it will try to make assumptions and it'll try to fill something in there for you instead of leaving it a blank. Storm and sewer. We've started putting all of that in. And we found this out on GeoNet, and I would like to advocate as much as possible. Share your CGA code, share your OBJ files. If you come up with something neat, put it out there and start sharing it. These models can be very time intensive. We should all contribute, and we should all share, and we can make better models and products out of it. Now, one thing you don't want to do, this is an excellent model, but when you're going to try to do a whole campus and you've got 3,500 of these things, don't bother going through the modeling of the rungs inside the manhole. It's just going to take forever to generate for you. So when you're looking at other models, try to keep them as simple as possible. It's nice that the manholes are off center on these, because that is reality for the way the data is, because you do have to have ladder access. You don't have the whole, typically you don't have the manhole in the center because you've got to get to the ladder to be safely go down, but you don't want to take and show it. If there wasn't memory constraint issues, we actually have photos looking down inside of all of these. We can apply the photos to the inside bottom here to show what the condition was the last time the photo was taken. Roofs. There are some good codes to take and add roofs. One of the issues that we found with roofs, though, was because of our existing data, we don't have many actual roof plans from AEC. So what we end up doing is ending with the top floor. We take and try to apply a generalized procedural rule to it. And because there's a piece coming out of the end of this building here, it interprets it as being a hip instead of a gable. And what we really need is a gable roof there. So what we're going to have to do in those cases is go back in and create a roof layer for it to properly represent on. There's nothing wrong with the code. It's doing an excellent job interpreting the vertices as presented. But as we're presenting, it's not reality. So we're going to have to go back and add those roofs in. Here's another case of roofs. We've got to add the dormer windows in here still, but it's doing a pretty good job representing what that roof actually is. So you really should ask this question before you start. We didn't, and we found out a lot of issues in the data, but you need to ask yourself, is all the height information there in your data? Do you have the elevation data there? Rotation. Working on a 2D web map, we really didn't think of rotation on a lot of assets before. Light poles. Well, it matters which way the arm is pointing. Fire hydrants. It matters to them which way the front of the hydrant is facing. We didn't have those attributes in there before. We don't have attributed roof types in our floors, and if you're going to take and pass them on to a CGA model to try to automate it, then you need to take in your floor and have an attribute in there for the roof type. Tree species, in addition to height, diameter is very helpful, and when the arborists are going through and doing all the trees, they with 17,000 trees there's a lot of misses and there's a lot of empty holes, and so you need to be able to handle that in your rules and how to take and apply those. On your floor plans, do your height and elevations add up to make sense? We found some buildings where some of the floors had the proper elevation and then some of them were down 100 feet off the ground versus 900 feet off the ground, which is what our elevation was, because they put in a base floor based on the survey, but they didn't translate that to the other floors. They knew the height, but they didn't finish off the translation. We've had floors that have crossed each other where they've intersected each other. Another one that we've got issues with is lining up. When you're taking on a 2D web scene and you're turning on one floor at a time, it doesn't matter that it's off by a foot or a few inches. You can't see or tell the difference. This was done back in the 60s, I believe, and at that point in time, the alignment for the sheets, and they were just paper sheets back then, wasn't big. And then when they took and they translated over, they didn't do a good job lining it off. But we've got a ton of floors like this that are not lined up properly, that we've got to go through and fix all of that. The other issue with floor plans is that there's not a good representation for stairs and steps on the outside, and that's an omission on what we have. We're going to have to take and do separate CGA rules for how to take and do the stairs that go up to here, or the ADA ramps to go into the sides and things. They're not part of what our standard floor plans have, so we're going to have to build those separately. Streets. Are your streets ready? Being the utilities department, we don't take and make the street maps. The university uses the county map to begin with, so that's what we started with. And we were having issues with things like here on the right-hand turn lane, how the intersection up there was working. This is a divided road, and when we actually brought that in the first time, we ended up with this, where it looks like something out of LA, where it's crossing over each other. Not a problem really with CityEngine, but it's a problem with how we built the network to begin with, or how we were given the network. We went from the county and we switched over for test trials with OpenStreetMap, and OpenStreetMap did a better job than the county did, but still it's not ready for prime time for us to be able to publish, so we've just taken that layer off for now. We've got to figure out who is going to do the funding to actually to fix it, because it's not a utilities department item, so we're just going to leave them off for now. Now it's hard to tell with this, but there's a lot of diagonal lines in here on the items that came in from PLW. That is not a PLW artifact. That is lines that are being put in by CityEngine, and it took us quite a while to figure out how to get rid of them. There is a tool for model cleanup that you can get rid of some of those lines, but you really don't want to use that for cleaning up the diagonals here. There is a script out on GeoNet that will take them out 100% and clean them up for you so that they don't show through. But we had a hard time finding that at first, and if anybody's run into that issue, send me an email and we'll send you the script for it. You can export the data from CityEngine into a lot of different formats. Right now, we're mainly going into CityEngine web scene, and we are doing some trials with going back out into Esri file geodatabases, and we're looking, depending upon who wins, whether it's CityEngine or Urban Circuits, that we might use View as the expert modeling for doing final generations. You can get photorealistic views off of the Eon software view. And then with any kind of export, you've got a ton of parameters in there for setting things. You can export the data from CityEngine into a lot of different formats. Right now, we're mainly going into CityEngine web scene, and we are doing some trials with going back out into Esri file geodatabases. And we're looking, depending upon who wins, whether it's CityEngine or Urban Circuits, that we might use View as the expert modeling for doing final generations. You can get photorealistic views off of the Eon software view. And then with any kind of export, you've got a ton of parameters in there for setting things. Web scene, our experiments with that right at this point in time, and I didn't put a visual in with it because it runs slow. We have not taken and tried to optimize our model to try to get it faster yet. We believe that to speed it up, what we're going to have to do is take these trees and make lollipops out of them so that they're a simpler model and you're not trying to take and model every leaf portion coming out. And part of the issue here is just how many assets we have when we're looking at a 3,300 acre campus. And this model here, even though we've only covered a part of the assets, we've got about 40,000 assets in there, and it's struggling to keep up with it. And here's another view in scene. It does come across. It's just slow to pan and move around. So city engines issues that we've had. We found a bug in 2015. It's registered. We're hoping that it'll get released, fixed in the next release, but there are some versions of FileGeo databases where if you've got domains in there, and we've given them a sample of the data, and it's verified that it's limited to 2015. They're believing that it's a domain issue that's causing the problem, but what happens is you take and associate your scene to a particular FileGeo database with a certain domain type in there, and then your scene gets wiped out. So we've had to take and move back to 2014.1 for our active work for most of it. There's some of it, like the sewer and storm, that we've had to keep in 2015 because there's things we're doing in there in CGA that's only available in 2015 and we can't port it backwards. So is a registered bug. Hope that's resolved soon. Size limitation for the image files. The big one relies highly on the graphics card, but that's true with any of your 3D products. But make sure that you're going to take and do testing as you go along on machines that you expect the end users to use this on as you're doing your development, because you can't take, we're developing on a server, and I've got 128 gigabytes of RAM, all solid state drives, 3 gigabyte graphics card on there, and got 16 cores on there, so I try to make this thing scream, okay? But anytime we do anything, we've got to go back to the desktop that we expect anybody else to look at and test it there to make sure that it's going to follow through and work. Because it's like if any of you are admins, you can make anything work as an admin, but you give it to the end user, it doesn't really work. Same thing here. Your graphics card, it's got to be within the realm of what your typical user's graphics card is. And if you're expecting something like this to go out over a web scene and you want to do over 3G or 4G, you better be testing early on because it's not really made for that. You don't have the graphics in there, graphics card capability that it really needs. CGA is not really a friendly user language. The easiest, I mean, they've got good documentation on what each function does. The easiest way to learn it is to take a script that works and then work it backwards, because some of it's just not intuitively obvious on how it works. And how you get some of the higher end things to work, you've got to stretch it a little bit to put the pieces together. And once you get to that point, it works great. But it's tough in some respects. The language of it is a little bit different. Even when you're going to search things, it was written by their Zurich crew, I believe. So even though they've got the words there, you trolley, tumble, and I've forgotten the third one now, but instead of pan zoom, you trolley and tumble. And when you're doing searches and the help and stuff, the way it's written, you've got to take in, if you've taken a European language before and can think a little bit in that realm, it helps you if you translate into how they're thinking first when you're looking for things in the help. But they do go through all of it, and they do show the independent objects very well. Just tough putting it together sometime. One of the issues, and we talked to them at the 3D conference about this, and they said that they were working on addressing it, is that the terrain color shows through when you're looking underneath. So for our utilities department, we're looking for where our electric lines are, where our sewer lines are and stuff, but when you go underneath the model, you see the color that's being represented on the top. And we'd like the capability to be able to change that to a more neutral color because it distracts from what you're looking at. Another big issue, yes?
You skipped over the SDE thing, and I was hoping you would talk about that.
Yes, all right. Cannot read SDE data directly. The claim at the 3D conference was that in 2.16 they're going to address that issue and fix it. So right now what we end up having to do is export a file geodatabase in 2.14.1 or below, and then we can read it in. If we update the data, we have to take in what we try to do is an SQL update of the file geodatabase, because if we remove the file geodatabase and put a new one in, then you have to reattach the rules to the objects. So it's painful in that respect. Because of the bug in 2015, what you end up having to do is go out to a shapefile. You can either leave it as a shapefile or convert the shapefile back to a file geodatabase and then attach to that. So yes, it's a big limitation. We want to change the data in one spot, the authoritative data source, and we want this to be able to read it. That was made loud and clear at the 3D conference before the UC this year, and I think they've got it. They say they're doing it, and it should be out in 2016. But
We're not the only one. Man, this hurts.
it does. It does. And we would never put it in production for the Esri people here. We would never put this in production if we had to have and manually update our data sources for this. It just wouldn't go. We need one authoritative data source that you'll read. Okay. Yeah, so can't connect to an authoritative data source. It's the same, really the same thing as the SDE. Can't tell what attributes are overridden. That's a very big one. In that when you are taking and reading your attributes from a file geodatabase or a shapefile, you have the capability of overriding what any of those values are for any individual object. So imagine you've got 4,500 light poles, and you're working with one and you're trying to tweak it in, and you've done some overriding with that. You can't take and close it and come back later and find out what's overridden without looking at all of them. So it's an area that they need to improve on. I spoke earlier about not being able to identify the individual object faces with indices. I mean, you do address it with an index, but you can't find out what that index is. You have to actually change something on it to find out which one you're looking at. Difficult to adjust perspective and path. Now, it's been stated in the Esri literature that this is not a presentation software. This is a modeling software, so keep that in mind. It's not being really billed as being the thing that you take to the regions and then have a path through to be able to show them what a wonderful campus you have. It took me a fair amount of time to get that flow through, to get it to look right when I went around campus like that. Most of that was my naivete or just not knowing it to begin with, but it doesn't have good fly-through capabilities. You end up going bookmark to bookmark, and you have to take and set every axis and angle and your view angle for each point when you're going through. They do take those bookmarks though, and you can take the first 10 of them and have them keyboard driven. So if you're doing a presentation, you can readjust your bookmarks so that the first 10 are the 10 that you want to look at. And that's how I did this one, is I put them in order, and then as it was filming, I ended up just hitting the 0, 1 through 9 key to get through the campus, and it faked a fly-through for it, but you can't adjust speed. So there's some of those areas where it would have been nice to be able to slow down and turn quicker, and you don't have that capability with it. But if you want to do that, you need to transfer it to a viewing software like Ion View to get your paths in it, to do the presentations in. And the documentation is challenging, which I mentioned before. So what's next for U of M? We got to go through, and we got a lot of correcting of 2D data to do. We've got plans for a new LiDAR flight to go next year. This is not because of City Engine, but we were planning to do it for other reasons also. But at the 3D conference, they were talking about doing extractions from LiDAR to be able to put into City Engine and their other products for what their roofs are, so that they could take and sense what, you give them an outline for a footprint, and it senses what the peak and the valleys are for the roofs, and will take and translate that for you. They did a demonstration of it. It looked very, very nice. We've got 1,100 buildings on campus. We've only got floor plans for about 700 and some odd of those buildings because of the different funding reasons. So the rest of the buildings we would like to be able to model, and we'd like to be able to extract them from the LiDAR. And with the new 3D tools that they're coming out with, we think that when we get the flight in next spring, the tools will be coming out in that neighborhood, and we'll be able to actually extract that data. We've got to add the stairs and ramps to the outside of the buildings and structures to the model. And then most importantly with the CE 216, to see if the current issues are resolved. And that'll make a big difference on whether we proceed or not, or we look for another area or venue. So is City Engine the right tool for us? It can produce excellent 3D models. It can do excellent cause and effect or condition statements, especially for planning office. If you've got it in 3D, you can take and throw a building up very, very simply, do shadow effects on it, and it's extremely good for that. For a utilities department maintaining it, for PMs and asset locations, jury's still out on that. Haven't decided yet. And compared to a 2.5D model, 2.5D may be good enough for us. We still have issues with misdig and stuff. We would like to be able to do horizontal boring with a little bit more confidence, but is it worth it? The jury's still out on that. So at this point, does anybody have any questions? Yes, sir.
Did you have 3D capable data for electrical duct bank? And if so, how?
So what we have for duct banks is we have every vault. We have the dimension that the duct bank comes out of every vault, whether it's a 2x, and it's the same thing, and we do plan to go to electrical. It'll be the same thing as we're doing for the sewer and storm. We have the invert heights, the height that the pipes come in to the sewer and storm manhole sections, and we'll be connecting them the same way.
So you're assuming a level duct bank run that doesn't do this?
If we don't have other information, so we have part of that electronically where we have it attributed in 2D, where we actually have the heights as part of the attribute. And then when we know there's a change in elevation, then we take the endpoint and it is there. For 100% of it, no. We have to make the assumption until we find out better. And then what we end up doing is symbolizing it differently for what the quality is of the data. So for the sewer and storm, we don't know 100% of that either. Part of it is we've gotten out into the trenches and we've taken points on it. Part of it is we've done scoping, where we know from scoping all the lines what the change is, and we know X number of feet out that we're doing a change. Have we done that with all the electrical? No. Other questions?
You had mentioned that
part of that infrastructure being tunnels that you're wanting permitting to do, does that include utilities through tunnels or just?
That includes utilities through tunnels. What we're actually doing with the utilities through tunnels is we are actually building that in BIM. And then we're going to be exporting that to the Esri platform via FME. So the reason that we decided on BIM for the tunnels is because we're doing a lot of remodeling in the tunnels. 60% of them were built between 1920 and 1940, so we're going through systematically and replacing them. So we want a record that we can give to architects to build off of to do the restructuring, because a lot of times what we do for tunnels is the piping is good as an intact. We end up cutting out the tunnel piece itself and then rebuilding the walls and not necessarily the piping. So BIM model we believe is better for that application because we've got miles of tunnel that we're going to be replacing over the next 3 to 5 years. Yes, sir.
Do you treat your tunnel more like a building than a utility infrastructure to come with?
We treat it like a building. So our tunnels, we've got 6 miles of tunnels. It's broken down into 9 separate buildings. And then we've done fake rooms in there. So we've got stanchions that hold the pipes up. Stanchions are typically between 10 and 12 feet. A stanchion will start the beginning of a room and the room will end at the beginning of the next stanchion. So we've created rooms for each one of those. All the assets are located in those rooms. And then we had to do that long before we put any of that on paper, just to be able to find it in our CMMS system. Because the CMMS system is based on rooms and buildings. And it's one of the difficulties in utilities when everything is outside the box and everybody else is thinking inside the building, how to take and make it work with everything. Other questions? All right, thank you very much. Appreciate it.